Hi guys, welcome back to the channel. Today we'll be discussing some more Linux commands. This session is specifically focuses on Linux commands such as links as well as the find command. So yeah, let's get started. As you can see, I am already located in the demo directory within the parent directory. The ln command, yes, the ln command basically is a command which is utilized for creating links between files. It can basically be used to create hard links as well as soft links. These links basically act as a reference to the original file, while soft links basically act as a shortcut um, by pointing to a resource location. The syntax for executing or creating these links basically follows this structure, where ln is the command itself, while the second part of the command structure is basically the option, where flags which hint the type of links would be mentioned, followed up by the specific target. Here there is also a third option whereby which you can also mention the specific name of this link that you are creating. So in a way, this link that is being created can be user defined. Hard links are a direct reference to the original file's data blocks. Therefore, whenever you delete the original file, it does not affect the actual link. So let us create this so-called link. So in this case we will be showcasing this particular file. Let's say we will create a new file called file.txt. So let's say we create touch followed by file.txt. This is an empty file, so let us echo some information into this specific file. File1 has been created. Let us append this information into file.txt and hit enter. When you type ls-l, you can see certain attributes associated with this specific file, and in this attribute data table that you see here, our point of interest is the second column. In the second column, each of these scripts and text files have a number present. This is the link which this number basically represents the link. So let's say we create a new file which basically stores a link to this file.txt, and this link that we are going to make is going to be a hard link. So in order to create this hard link, we will type something like ln followed by the name of the file of our interest, which is file.txt, followed by the new file which would store this information. So this would be hard link.txt. So once you hit enter and if you type ls, you would see that this new file called hard_link.txt has been created. Let us now view the attributes. So you can see this, that in the details attributes in the secondary column, you can see that from our previous case the link number has been updated by 1. This is indicative of the fact that now there exists one extra link between file.txt and hardlink.txt. So what has happened here is that in Linux, whenever you create links, each of these files basically have an inode number. So the concept of links basically revolves around the idea of inodes. Inodes basically are wait a minute, yeah, I hope this screen is visible. So inodes basically are fundamental part of Linux and Unix file systems. These basically store information or metadata about the files and directories, which basically acts as an address. So it basically points to the file's data blocks on the disk. Every file and directory that we have ever created has an inode number, which is managed within this file system. So you might wonder, what is this metadata that we are talking about? So here, when I go back to the to my Ubuntu virtual machine, you can see that whenever these attributes are displayed, this is the specific information that is being stored within these inode numbers. This would include information and descriptions about the regular file, if this file is a directory, or whether they have symbolic or hard links, the kind of permissions, read, write and execute, and which members of the network have this specific access, followed by the owner ID, the group ID, the size of the file, the number of hard links or soft links, followed by the latest date of modification and the addresses. The inode is therefore basically a unit or a data structure which basically has this specific information that we have showcased over here. However, note that inodes do not contain the file name, as that specific information is stored separately. Moreover, the actual file contents are not there in these inodes, but these are basically pointers to the data block. So this basically refers to an actual physical space in the memory. So in order to depict the inode information for all these files, you would basically write something like ls-li and you hit enter. Once you do that, you would see that a new column has been added to our details table. So you can see that these arbitrary numbers are in fact the inode number, and since we have created this specific hard link between file.txt and hardlink.txt, you would see that the inode value for file.txt and hardlink.txt are the same. So going back to our example, to our diagram, you would see that the hard link that we have created here in the case of file.txt basically points to the exact inode, and if you make any change to file1.txt or to hardlink.txt, these changes would be reflected in both. So what has happened in fact is that the inode number, basically, which is a reference to the physical information in your memory, is reference to these two files. Therefore, if you change this information which has this specific inode value attributed to these two files, the changes get reflected back to these two files. Now going back to our example, to our workspace, if you type ls-li followed by the name of the file, here let's say hardlink.txt, you are getting this specific information associated this specific text file, and you can see that the inode number has been depicted. So in this file system organization, there is a comprehensive and dynamic flow of information happening across inodes and file names. So you can basically work with these two together. Moreover, to add to this complex structure, directories also have special mappings between the file names and the inode numbers. So you would see that if you let's say if you try to, let's say, ls hyphen li followed by, let's say, sub. Okay, let's try to move into sub. Yes, li. So similarly, within this entire inode structure is present within the file directory system, and there are no exceptions. Moreover, whenever you rename files, the name might change, but the inode number which has been shown, it remains the same. So hard links, in addition to directory entry, which basically points to the same inode number as the original file, they have the same inode values since they point to the same physical space, physical data on the disk. Whenever a deletion happens, let's say if you delete, let's say we are going to remove, we will have to move up one level up, and let's say we are going to, let's clean our workspace. Let's say we delete rm hard link .txt ls -li. You would see that the actual data with regards to the inode number, which was same for both, would remain, and no actual data is deleted. So previously I had mentioned that whenever you make any changes, let's go back one level up and let's create this hard link .txt again for this specific file, ls-li, and let's say we try to write some extra information into file.txt. Before I do that, I would like to showcase the contents of file.txt and hardlink.txt, since you would see that the data that I had previously stored into file.txt is the same that is being reflected into hardlink.txt. And let's say if I type some extra words, let's say this is being appended to file.txt, and I append this information into file.txt, and I basically try to see if the content has changed for file.txt. You can see that this information has been appended, but the true nature of inodes will be revealed once I showcase the information for hardlink.txt. So as you can see, the concept here is that links basically refer to the same inode number or value, which basically is a reference to the physical data on the disk, which is referred into these two text files, and any change which happens to these two to this particular information associated with the same inode value would be reflected. So yeah, so again going back one step above, so when you delete the hard link, the actual data is not affected. Going back to our diagram, let's go back to our diagram. Yeah, so now let's just recap what we just did with the in context of hard links. The key points about hard links are as follows. They basically use the same inode number referring to the same data block, a physical space within the memory. Any modification to one file would modify all the linked files. You cannot link directories. Moreover, this would work within the same file system. Deletion of data would not affect either of the associated files, since the actual data is not being affected. Similar to this, let's now move on to symbolic links. So I'd like to clear my workspace. Let's go on with the next example. Let's say we create a soft link. So in order to create soft links, you would basically follow the same structure as before. Let's say like this, and then you would write the name of the new file that is linked to this specific text file, and once you hit enter, you would see something very different. So what has happened here is that you would see that the inode number for the softlink.txt is different. Here we can see that the inode number for file.txt is 1073, while for softlink is basically 2195. But if you look over here, you would see that the softlink has a special character which basically is pointing to the original file. So what has happened here is that unlike hard links, if I try to just show off the contents of this specific file, this basically acts as a reference. In the meanwhile, as you can see, once I have displayed the contents of hardlink.txt, it basically refers to the content which is present within the inode number. Let's just showcase that information again. You can see that since the inode number was unique, was uniquely being shared by the file.txt and hardlink.txt, upon the deletion of file.txt, the data within file.txt would be lost, since it is directly referring to this particular inode number. However, deleting file.txt has caused softlink.txt to basically break the soft link, since softlink.txt was basically accessing the data present within 1073 inode indirectly through file.txt. Once this was deleted, this soft link became broken, and once if you try to display the content of softlink.txt, it would showcase that such a file doesn't exist, because now the contents are not being shared, which was not the case before the deletion of file.txt. As you can see, the data was accessible until I deleted file.txt. So yeah, this is pretty interesting way of working with links. So yeah, I hope this wraps up your understanding about links and its various uses. The next command that I will be talking about is the command called find. Now, the find command is not a command which is directly installed on your default system. For that, you would basically go about doing sudo apt install find, and then when you hit enter, it would basically go out and get the data, get the specific version of find, the latest version in this case, and install it on your system. The find command is one of the most powerful tools in Linux, as it allows you to search for files as well as directories based on the criteria, let's say in reference to the name, size, type, or permissions, as well as the latest date of modification. The typical structure or syntax basically would look something like this, where the first part would be the starting path, followed by the secondary parameter being the option, and the third parameter being the expression. The starting path basically refers to the directory where you would be searching, while the options basically refer to criteria such as names, types and size, while the expression basically refers to the actions which are required to be performed, which might be delete or print. So let's try to do this. In this case, if I try to find, let's say we are looking for a file name file.txt in our current working directory, we would type, let's just make sure we have a file. Okay, we do. So when we do this, find dot, let's search by name followed by the name of the file, which is file.txt, and once you hit enter, it would basically go up the entire file structure and basically look for the whether this specific file that we are intending to look up exists, and basically returns the file path. So here we are able to locate file.txt in our current directory. Let's say we are now looking for directories. We can do something similar. So here we can look up a directories by name. So we type find dot followed by type, let's type D. So yeah, whenever you search for directories, then the entire structure later basically remains the same. So let's say we want to look up let's say demo. So yeah, here you would basically add this flag hyphen type D whenever we are interested in searching only for directories. Otherwise, if we are looking for some text file or some bash file, then this would be not required, and once I hit enter, it would showcase me the entire file path to the directory of my interest. Let's say we do this for directory as well. This works. Let's say we basically look up for files which in context of insensitive typecasting. Let's say the text name can be large or small, so capitalized or uncapitalized. So let's say that's the context of ignoring the case. So we basically would type something like find name, something like this. The structure remains the same. However, instead of hyphen name, it would be hyphen I name followed by the name of the file that we are interested in. In this case, let's say we are looking for file. Yeah, let's see if there are any. Yeah, so for the purposes of this, let's just randomly create a new file.txt and let me again run this. So you can see that though the cases of the text files are different, file.txt, though it is capitalized, the first letter is capitalized, irrespective of that detail, that specific information has also been displayed. Similarly, we can also search for empty files. Let's say we can look up for files based on the type. Let's say we will look for empty files. So for that, we will basically follow this command structure, and once you hit enter, it would list out all the files which are present, which are empty. It would include log files, empty.txt files, and so on. We can also do the process of filtering out or finding up files with regards to whether they were created the latest or so. Let's say we can basically list out all the files which were latest created or modified within the last 7 days. So when we hit enter, it will show all the data associated with the files that were created in the last 7 days. So you would see that this dot if I forgot to explain this, the dot here basically explains we are basically looking into all the files. However, let's say if you are interested in looking up let's say we can let's search up directory file folder with regards to this data associated with the latest modifications within the last 7 days. So you would basically write the specific directory that you are interested in, and when you hit enter, okay, let me do this again. Okay, yeah, so when you hit the address, the specific name of the directory that you are interested in, and when you execute this particular command, it would basically show you the latest files which were modified on those dates. So this is pretty useful if you are interested in deleting files as well. Let's say we are interested in removing all the empty files. Since those are of no value to us anymore, we can simply use the same command as before and basically append this specific detail to the command. So once you hit enter, okay, let me do something different. Let's see what are the files which are empty. So let's say we are interested in deleting the files which end in .log, and let's try to delete all these files, log files, which end in the term .log. So that would include all the log files, and let's delete them. So once you hit this, and when you do this, you would see that from our previous command, log files quirky and qwerty, and also qwerty123 log files are no longer present in our list of empty files. So this is pretty useful whenever we are interested in permanently removing files that are of no use to us. But it is very essential that you understand and use this specific command structure, because it can permanently remove certain files, and it can be unsavory if certain important files get deleted. So to summarize, you can basically find files in context of their names. You can also search for files in a insensitive format as well. You can basically search for files, and you can basically search within directories. You can also search for files which were modified, also search for files based on the latest information. Like let's say we are listing out all the files which were modified within the last 7 days or so, it can be done as well. We can also list out files which are empty, which can also find files which need to be deleted with the help of the delete tag. So yeah, this is pretty useful, and you can basically use these commands in a very specific order whenever you are working in large file systems, especially in a workplace context, which would not expect you as a user to go and perform these tasks manually. So yeah, I hope you found this useful, and I will see you in the next one. Bye.